This is one of my favorite parts about the Triceratops. They didn't just have teeth, these guys had shark teeth and a beak. Okay, so today we're going to talk about the Triceratops and how it came to be. This is the first of my educational videos. I am Hobart. I am with my brother, David. Say hi, David.
Hi, David.
Let's begin. This video is I'm going to attempt to cover as much as I can in the history of how the Triceratops came to be in the evolutionary history. I also want to paint a picture of its environment and what plants lived. I want to get into what made Ceratopsians unique, and also what were they doing and what were the horns and frills for.
I'm definitely excited about the evolution, the talk about the plants and stuff like that.
Yeah, so there will be a section on plants. That was actually, I'd say in my research, it actually took the longest. But we're also going to talk about the Triceratops Ontogeny, which is the growth cycle. Yeah. In 1887, a man by the name of George Cannon found a pair of horns connected by a fragment of skull. He knew it was significant, so he sent it to Othniel Marsh, who is a famous American paleontologist. You might recognize him from the Bone Wars. He noticed that they were cores of much larger horns, much like bison, and so he gave the name Bison alticornis, and not knowing it was from a dinosaur at the time. The very next year, John Bell Hatcher, in the river formation in Montana, he found another pair of horns, as well as
the neck ball in the back there.
Yeah, as you can the Triceratops had a ball joint where the skull attached to the neck, and he also found that, which I'm not sure if they knew it as a dinosaur just yet, but they did give it the name Ceratops, which is
what they called it before the Triceratops.
Exactly. This is actually not considered a species because there wasn't enough animal to
really classify it. Yeah.
The same year, Hatcher also found a third skull. This time it was a lot more complete.
Yeah.
With the help of Marsh, they gave it the name Triceratops Horridus, and it became the first Triceratops. I think at this point, Marsh also renamed the first two horned dinosaurs, the first two horned specimens as dinosaurs as well. John Bell Hatcher was an amazing paleontologist and fossil hunter. He was known as the King of Collectors. After the Triceratops was described, between 1889 and 1891, Hatcher collected another 31 Triceratops skulls.
Wow.
And he's also known for finding and naming the Torosaurus, which is essentially just a really big Triceratops.
Oof.
This is very late Cretaceous here.
That would be really imposing to meet in the forest.
Yeah, that frill is just massive.
Well, you can see how big it is just from the display.
Yeah, I think this is 10 feet at the shoulder here. This is a big animal.
Yeah.
Let's look at the evolutionary tree of the Triceratops. This is a simplified version, but this is the tree that I'm going to go off of for the most part in the video. But if we wanted to look at a more realistic tree, this is what this is going to look like. But we're going to start right here with the Ornithopods. The Ornithopodia really set off quite a bit of dinosaurs, well known and very successful throughout the entire Cretaceous period.
It certainly seems to have a very efficient way of being, existing, where it's hunched over, the tail is balancing it, and it's able to grab and pick food.
Yeah, it can reach the ground at this point. Yeah, exactly. These are tiny.
And run.
Yeah. They're found in late Jurassic, which means about, I want to say 150 million years ago. They lead to many famous dinosaurs like the Hadrosaurus, the Iguanodon, the Rhododontidae, the Parasaurolophus. And by late Cretaceous, it became extremely successful. And they were known to have some of the best teeth dentitions of any non-avian dinosaur.
Look at that thing.
Now, it looks like a wall of teeth, but that's rows of teeth melded into one. We've got better pictures of it in later on. So those are all related. Now remember, this is not on the way to the Triceratops just yet. These are just the closest relatives. Even closer cousin to the Triceratops is a Pachycephalosaurus, which is a headbutt dinosaur. They share a lot of features, including a shelf for the back of the skull. Yeah, there's very little evidence of this dinosaur, to be honest. This is a late Cretaceous animal. The dome of the skull was around 25 centimeters thick and made of temporal bones, which means that they healed much more quickly. This is known to be like a tumor type bone.
Right. And it would make sense that it didn't have skin on top of it, because if you're hitting stuff so hard, it would probably just break the skin.
Yeah, I'd agree. This is the thought, at least.
Right, that's the idea.
We don't know what they did, what kind of skin they did have, or color. But they were approximately, or thought to be approximately 4 to 4.5 meters in length, weighing around 1,000 pounds. But the excavated bones only belong to babies, not adults. So we're just really guessing, I think, in that.
I would be surprised, in the sense that we're still looking.
We can tell because the bones are not mature all the way, and the skull is actually not a very perfect dome. It's still maturing, it seems. Next up, this is now on our way, and the first Ceratopsian, the Psittacosaurus, which is a very well-known dinosaur. We have more than 400 specimens found, mostly in China. They were about 2 meters long, so 6 feet. So that's actually, I'd say they were about wolf-sized.
6 feet's a lot.
Yeah, 6 feet, but that's head to tail.
That's a person laying down.
Yeah. So they're about a legit wolf, like big wolf.
Yeah, you definitely don't want to get bit by that.
Yes, this is a big head, very powerful bite.
Little hands for probably manipulating.
Yeah, they did
food.
have grabby hands. Bipedal. Yeah. Nothing like you would never expect this to be the Triceratops. They were roughly 45 pounds, so not very heavy.
I was gonna say that's pretty small.
Yeah. They took about 10 years to reach maturity. We know, in detail the ontogeny, how they grew up, how long they took, and what they looked like along the way. For the size of these dinosaurs, they had very large brains, which makes sense of the size of their head. It's mostly found in Asia, so it's believed that the Ceratopsians originated in Asia. They were beaked with teeth. There are 11 different species named, and that is the most of any non-avian dinosaur. The really cool fact is that they were quadrupedal as babies and bipedal as adults, so they changed the way they walked as they grew up.
So it's a non-avian.
Mm-hmm. They also changed diet as they grew, which typically would mean that the young hunted for themselves, which they would eat something different because of that.
Right. They speculate that the adults would probably attack the young, so the young, kind of like baby turtles, probably went off on their own.
The young had worn teeth. They had primitive feathers along the back of the tail, which is a really cool fact, and thanks to some really well-preserved animals, we know this.
And they weren't like feathers today.
Mm-hmm. They only had 4 digits on their hands. The hands could not rotate, which means they were stuck in a chopping position.
A hinge joint.
Yeah, exactly.
With no twisting.
Yeah.
Bones.
The next that we have Archeoceratops. This is a really interesting one, and it's starting to get the frill now, and the head is still quite large compared to the body. I guess it means ancient horned face.
It's certainly getting to be more scissory, picking what they eat.
Exactly. Yep. Very thin mouth. They do still have teeth inside their beak and behind their beak. So the 2 sets of teeth with a beak. They were found in Asia still. This is where their jaws started limiting motion. They were only limited to vertically shearing, which means they could only move their jaws back and forth as opposed to around in a circle, if you would imagine a cow or a horse chewing.
Right.
They lost the ability to do that. Once again, they were quadrupedal as babies and bipedal as adults. And this time they were about 1 meter long. There's only 2 specimens found, so we don't know much about this dinosaur. All right, the Leptoceratops. Now we're getting even bigger frills, even bigger skulls, and I think this is beginning to be completely quadrupedal its whole life. This is now found in Western North America. This is a little bit bigger now. It's about twice the size, at 2 meters long, 6 feet.
Does that mean that it also ran on 4 legs?
Yes. So this picture looks like it's down, but this was a fully quadrupedal everything. They weighed about 100 to 400 pounds. The frill is starting to be much bigger, resembling much more, much of the larger, later ones.
Right.
The teeth are also becoming a little more complex now in the tissues and the level of tissues in it, like how many tissues. Now we have one of the most famous of the Ceratopsian family is a Protoceratops. Once again, this is a very well-known Ceratopsian with over 100 found, mostly in Asia. They were about 2 meters long, about 6 feet, up to 400 pounds, and the beak still contained teeth.
Dang.
The frills have become much larger, and they had much larger heads. Once again, the heads just keep growing.
Yeah.
They're still found in large groups, which is really cool. I think for the most part, in most Ceratopsians, they're all pretty much found in large groups.
We're definitely seeing a pattern here with the head. That's probably one of the big things. Actually, the thing they're most known up for is just the sheer size.
The size of their skull. Ceratopsians end up, in the end, the Ceratopsidae have the largest skull of any creature on the planet outside of the ocean.
Right. Outside of the ocean.
Yeah, we can't forget about whales.
No.
In Western North America, we also find this is now only Western America from here on out. The Protoceratops is known, I think, it's a Mongolian, famous in Mongolia, like whenever it was fossilized, seemingly in battle with Velociraptor. Yep, there at the bottom. Yep. This is about 90 million years ago, found in New Mexico. It weighed about 175 kilograms, which is about 386 pounds. And now about 3 meters long, so 10 feet. So we're getting a little bit bigger in size now and closer to the Ceratopsidae that we love so much.
Right.
It's now got horns for the first time. The Protoceratops did not have horns. It began the big frill, but it was lacking in horns. And as you can see, there's actually a slight nose horn as well. And they're close relatives, if not predecessor to the Ceratopsidae. This is a very, very successful group that lived for a very short amount of time, but just went crazy with diversity.
Thought of very similarly to the birds of paradise, in that they just, it seems like the frills got something going on with their diversity.
Yeah. For the most part, the teeth and body stayed the same, other than the teeth becoming more, I think they really gained in numbers throughout the time, but they didn't change much. By late Cretaceous, Ceratopsian made up to 2/3 of their ecosystem, which is absolutely crazy. That is just food. I'm just thinking, like, the reason the T-Rex really was able to get so big is because they were just completely supplied with Ceratopsian meat.
They had all the resources that they could eat with that size of body.
Mm-hmm. For the most part, they lived in mass herds.
I think you would have to if you're going against T-Rex, who probably didn't hunt in herds.
Yeah. The Ceratopsidae was made up of 2 large groups, the Chasmosauridae and the Centrosaurinae. The Chasmosauridae typically had large eye horns and a small nose horn, where the Centrosauridae typically had small eye horns, if any eye horns, and then a large nose horn. But recently we found some exceptions, so it's not really the rule of thumb. There is an enormous amount of diversity with these. On the Centrosauridae, we have my favorite, the Styracosaurus, which is just, I wish I could see this in real life. It's crazy. We also have the Pachycephalosaurus, which actually doesn't have a horn on its nose. It replaced it with what's called a boss. A massive bone, like a punching ram, a ram, There's also some that look a lot like the Triceratops. I think this is a very early one. Maybe it's also right where they split off, where it became the Chasmosauridae. But in the Chasmosauridae, we have the famous Triceratops and the Torosaurus. Let me get into the environment and climate. The average global temperature was about 29 degrees Celsius or 85 degrees Fahrenheit. Today, the average temperature is 17 degrees Celsius or 67 degrees Fahrenheit. So there is a massive difference in temperature. This led to a much higher ocean level.
Okay, because of the ice caps.
Exactly. There was no ice caps. Well, there was ice in the winter seasons, but there was no ice all year round.
Right. Talk about tide.
Yeah, technically, right
Seasonal
now,
tide.
today is still in an ice age.
Yeah, but we still have pretty large amount of ice up there. That's for sure.
Yeah, because of the way physics work. Whenever you heat water, it expands. You know, if you were to fill a pot of water, draw a line where the level is, and then heat the water up, you will notice that the water has gone up in level just because you went up in temperature. So when you go an entire planet of ocean, raises that much, it's going, I think it was, it's 90 meters or 295 feet above the current sea level. And this created a sea right in the center of the United States, as you see there.
And it's down in Texas, we always know those as the ancient lake beds, and that's what we were talking about when Texas talks about that.
Exactly. The large horned ceratopsians are only found in La Ramidia. It's thought they got the start there and just never made it out. They really weren't on the planet for very long, which is crazy.
Yeah, when things change, man. They really change.
Now for the exciting part.
Yes, this is my favorite.
What type of plants existed at this time? We have cycads, which they're for the most part, they're unbranched. They're woody plants resembling a pine. Cycads flourished during this time, but today they're almost gone. I wonder if that looks like like when I see pictures of Vietnam or videos of Vietnam, this is the type of tree I'm thinking.
It's definitely a tropical plant.
Yeah. Yeah, it's only found in tropical areas today. Yeah. Typically, they have a crown of large and stiff evergreen leaves, much like ferns.
I think a more primitive, like it's not as intricate as, say, an oak leaf, where it has veins going in through every little crevice thing. That's like thicker veins that have less complicated pathways.
Correct. These plants have male and female versions, which is...
It's common in a lot of trees.
Yeah, especially the older ones, I think.
Conifers.
They typically grow very slowly, which a lot of the ancient plants did. Yeah. We also have conifers.
Like male and female pine cones.
Exactly. Yeah. These are the cone-bearing seed plants, primarily wood.
Now, the cool thing, so what they mean by carbon sink is that it takes carbon to build them, and even though some of it gets away when they die and they decompose, a lot of that actually is turned into oil later on as it gets down and deeper in the soil every time it rains. So just about all of the oil that you see underground is typically made from plants, because there just wouldn't be enough animals to make a big enough difference to say, that's worth mentioning.
Exactly. These are mostly found in colder areas, which is actually surprising for the planet, so they probably didn't flourish very well at this time.
Well, they relied on there happening to be a male tree upwind.
Yeah.
Which is easy, but they didn't have the help of like bugs or bees.
Exactly. These are not flowering plants. Yeah. So there were no pollinators, so they just sent their pollen into the air. Yeah. Like if you park under a tree and you come back and you see this like yellow coat, that's what those trees do. They just send it out and hope for the best.
Yeah. And it's not the only kind.
Today they make a great economic value for the softwood and lumber and also paper production. We also have angiosperms. So this is really unique. These are the flowering and fruiting type plants. They have very, very complex seeds. These didn't come around until, I think, early Cretaceous. And when they came to be, they flourished and they dominated. And today, typically, if you're going to think of a plant, like in your head, say think of a plant, chances are you're thinking of an angiosperm.
Well, they probably just have a vastly superior way of producing babies because of the relationship that they develop. Like they wonder what came first, the pollinators or the flowers, and the answer is just about always they grew up together as a symbiotic relationship.
Exactly. So they developed smaller pollen grains that really made a good successful thing. And also the big The biggest successful drive is their seeds. And these seeds created nutrients for the plant to grow, so it didn't have to do much of the growing on the plant. So the trees and plants are now able to spend less energy reproducing as opposed to where it was before. This probably drove their success. They were also much faster growing plants too.
Certainly numbers make the difference between winning and losing a game.
Exactly.
The game.
Okay, why were the Ceratopsians unique? We'll start with the jugal bone.
My favorite.
This is going to be the cheekbones, beginning with the Psittacosaurus. By the Triceratops. The Triceratops have massive cheekbones. Some of them are just crazy out. You'll see them on every single one. The top in the center is Psittacosaurus.
Oh, I see.
We have Zuniceratops. That's the Leptoceratops, I think. And then Protoceratops there.
It took me a second to figure out which way was the front of the one in the middle there up on top.
Yeah, those are huge. That's the Psittacosaurus really, like, that's the beginning of the jugal bones too.
Yeah.
We also have a very complex teeth dentition. This is one of my favorite parts about the Triceratops. They didn't just have teeth these guys had shark teeth and a beak. These are now second to hadrosaurs having the most complex teeth dentitions. They're made up of up to 5 tissue types, so as they ate and as it wore, it stayed sharp. And they also had rows of teeth, so as they lost teeth, they had, as every dinosaur did, they replaced teeth, but they were able to replace it without leaving gaps. So it's known as a tooth battery, and this is such a cool aspect.
Coupled with the fact that it doesn't move its jaw side to side anymore.
Yes.
Now it's doing a circular up and back and forward motion. So it's sawing the teeth together to chew on the very dense fibers of the plants that it ate.
Exactly, and that's what the theory is that they the reason they were so successful is because they were able to develop a way of eating the really tough and low in nutrient, probably conifer type
as
plants.
Most successful grazers wind up doing, kind of like horses and the relationship they have with grass.
Exactly. All right. The frill at the back of their skull. This is an obvious trait that sets the Ceratopsians from most things.
It's the one in the middle for sure is a very interesting shape, and what it didn't look very strong.
No, this is the mid-Cretaceous Zuniceratops. This is the one that we think led to the larger horned dinosaurs.
Yeah, and I imagine the jugal bones probably did a fair job of protecting the eyes.
I bet. I'm sure.
That's
yeah, exactly. So this is the first 3 neck vertebrae are fused, called the synocervical. This is probably due to their massive skulls and weight of the skulls. It probably needed that. I was speaking to a local paleontologist named Alan who dug up Bob the Triceratops. He was digging up an even bigger Triceratops than Bob, and one of the bones he has already was this bone, and I got to see it, and it's really cool. This is a really bad angle. It's longer. The A on the right diagram is probably a better representation of it right there. What were their horns and frills used for? Now, this is a really interesting topic and highly debated amongst paleontologists. There's a lot of evidence of vein canals. These frills were pumped full of blood, typically believed to
change the colors. Yeah.
And it was also for they had a very keratin-like skin, much like the beaks of birds. So they had a very tough skin throughout their whole face, and this is also on their frill. But because of that, it's also thought that if they were to take a bite there, they'd probably bleed a lot. So this is probably on the argument towards display over battling.
Or, yeah, in the sense of cooling, because if you've got that thick skin, you need something to be close to the air.
Mm-hmm. Today, pretty much every example of horns, from beetles to bison, are pretty much display only, although they could use it for defense if needed.
Yeah, just like, a horse in their foot.
Exactly. Another argument against defense is some horns don't correctly, they don't point in a way that you would think to be defensive, such as the Ankylosaurus here at the right. Unlike most ceratopsians, the trike actually had a really thick and robust frill, which kind of makes sense because the Triceratops lived a different lifestyle than most. Other than pretty much every other ceratopsians found in large groups, the Triceratops is solely found alone. I think there's only one example where there was a bone bed of 3 individuals, but they were all juvenile. The Triceratops is actually found to have a lot of scarring on the frill and face, to where they fought mostly each other. The scars were found, which makes sense for mating rituals, to see who's mating with who.
And kind of like giraffes, they'd probably sit side by side.
Yeah.
And smack each other until they gave up.
Yeah, I wonder, man, if they were like poking each other with those horns, they must have had some really tough skin.
Well, yeah. I mean, have you seen giraffes fight?
Yeah. Well, I mean, let's talk about. I mean, even deer and like.
Oh yeah, where they run at each other with those pointy sticks.
Oh man,
yeah,
that's crazy.
Of course, those are not bone. These are bone.
Yeah, exactly. Yeah, exactly. These are not keratin horns. These are bone horns. So they're thought to. The Triceratops, the horn was thought to be so strong it could actually pierce a car and be strong enough to probably lift the car up. This is a very strong bone.
And it's not even the only place we see this sort of shape. The horned beetle, I forget which one it is, but it also has a sort of closing grip of bone or sort of horns, and they use that to lift and throw their opponents.
Yeah, exactly.
I mean, they won't be able to throw much bigger. I imagine they'd be able to throw, but something smaller.
Yeah. This also thought that the frills were used for thermal regulation, because these are massive creatures, and the big problem with becoming large, especially during a very hot time of history on the planet, you have to figure out a way to lose your body heat. The reason that whales are able to go so deep and stay alive is because their massive size keeps their body heat regulated. But much like elephant ears, this is probably used to cool off their bodies, and they were blood-filled, there's vascular evidence, so it would work as a cooling agent.
All they would have to do is just wiggle their neck, and their frills would catch the air.
We'll also see evidence of very large nasal holes, which is another evidence, or thought to be evidence of thermal regulation.
Yeah, where they just pump gallons of air through their face.
I'm curious to know how they breathed, if they breathed like birds.
Right, with the two holes, yeah.
Yeah, that'd be really cool, and that would actually, I don't know, these guys are already really cool, but that would just make them so much cooler.
Yeah. LOL, pun intended.
Okay, let's talk about the ontogeny. The Triceratops, we know very well of how it came, how it grew up. At the beginning, as a baby, it started with the small and deformed frill. When it became a juvenile, the baby also had horn nubs. By the time it hit juvenile, it started growing horns above the eyes and the nose, and it also developed bumps around the ridge, out the edge of the frill, the rim. Their horns also, at this point, they were pointing up, and as the Triceratops grew, those bones around the frill fused to the frill, and the horns became straightened and then grew out and grew forward. As it, by full maturity, it pointed forward, which is a really cool fact. It baffles me that the Triceratops horns changed shape as they grew.
Right, and that's what makes it kind of more in a sense of they used to probably use it for more than rituals, or like a peacock would with their for mating, I should say. But it just because it can be used for mating doesn't mean it can't be used for attacking or defending.
Exactly. I remember watching a video on a guy who did his thesis on the sexual dimorphism, like, the difference between male and female on the Triceratops, and he went on and on about the different studies he did with horns and pretty much everything, and he found no evidence of sexual dimorphism in the Triceratops, but we don't know what color it was. I imagine that the colors were different, and maybe the size.
They could really be anything in the sense of if they didn't need camouflage because they were so big, they could have been bright colors.
Yeah, I like to think that their frills, when they, not the Triceratops, but other Ceratopsians had holes in them. That would be really interesting if they had dark spots. I don't know if it would look like eyes, but in a mass assemblage of, if you were to look at a massive herd of Ceratopsians, you would just see a bunch of frills and horns.
Yeah.
Imagine a herd Styracosaurus. If you looked at a herd of Styracosaurus, it would look like a thorny bush.
Yeah.
Just horns everywhere coming out.
Jeez.
Gosh, that looks so cool to think about.
Don't mess with those guys. They're not messing around.
Yeah, Styracosaurus is the coolest, man. A massive nose horn too. Like a long rhino horn.
Well, it would make sense. That's why they're able to develop the sort of pointy face for, getting what they want out of food instead of just like eat and run. Because they actually had the time to be like, oh, you're trying to screw with me? We're not going anywhere. We're going to kick your ass.
Well, that completes the video. I hope you enjoyed this. If you want me to cover another dinosaur, let me know in the comments. I want my next video to be about the Tyrannosaurus, and I can't wait to learn about that one for sure. I also want to do sauropods, but let me know what you want.
Yeah, this has been fun. This has been Hobart Obsessions with John Hobart and David Hobart, and we'll see you next time.
Thanks.